All right, welcome back, guys. So we just finished up simplifying radicals. We are now going to be on to our next unit, which is called the real number system. For those of you guys that don't like adding and subtracting, simplifying, multiplying, dividing, solving equations, all that sort of stuff, you're gonna like this unit because basically this unit is just identifying where numbers fit. So you don't really have to do anything fancy with the numbers, you just have to figure out where they go. So today we're going to talk about where or how we can classify numbers in the real number system. All right, so we're going to start in the very center of this Venn diagram in what are called the natural numbers. Now, natural numbers are the numbers that you first learned when you were learning how to count. They are very simple numbers like 1, 2, 3, etc. Okay, so natural numbers are any of those numbers that are nice whole numbers, all positive, and you can count. So 1, 2, 3, 4, etc. Now, the next numbers are what we call whole numbers. Whole numbers are almost the same thing as natural numbers. The only difference is whole numbers include 0. So whole numbers are like 0, 1, 2, 3, etc. Now, if something is a natural number, that means it's also a whole number. Okay, so if it's in this box, natural number, it also is going to belong to all these boxes outside of it. The reverse is not necessarily true, but we'll talk more about that in a few minutes. All right, integers are the next sorts of numbers that we're going to talk about. Integers are just negative and positive whole numbers. So numbers like -5, +2, -4. Notice no decimals or fractions, but they can be negative or they can be positive. Okay? So again, if something is natural, like the number 2, it's also going to be a whole number and it's also going to be an integer. Okay, so it's going to fit all those different categories. Now, rational numbers are any of these types of numbers, so natural, whole, integer, and they're going to include our fractions and our decimals that stop. So they're going to include numbers like 2, they're going to include numbers like -5, and they're also going to include numbers that are fractions like 1/2 or 0.45. Okay, these are all going to be examples of rational numbers. Now notice 2 was a natural number, it's whole number, integer, rational. Okay? Now, if it's none of those things, then it's going to be irrational. Irrational numbers are numbers that do not stop and do not end. So the classic example is the number pi. If you put that in your calculator, you get that huge number, 3.14159,625. That goes on forever and ever without stopping and without repeating. Okay, so we'll talk more about irrational numbers probably tomorrow, but those are the types of numbers we're going to be looking for irrational numbers. So your goal today is going to be, I'm going to give you some numbers and you have to figure out where they go. Okay, so on the quizzes assignment, you're going to get a number like 6. And you're going to have to try and figure out where 6 goes. So you have to ask yourself, is it a number that I would count? If it is, then we say it's a natural number. In this case, 6 is a natural number, so I'm going to put that here. Now, if it's natural, it's also going to be whole, it's also going to be an integer, it's also going to be rational, and anything that's in any of this paper is also called a real number, which is why it's called the real number system. So 6 is all of these things. All right, next I'm going to give you an example like -4. Now -4 is not natural. We didn't count going 1, 2, 3, -4. Okay, we count just with positive numbers. So -4 does not fit in there. -4 is also not a whole number. Whole number is just 0 in those positive counting numbers. -4 is, however, an integer. It's a negative whole number. So we're going to put that here. And if it's an integer, it also means it's rational and it's real. So -4 would be an integer, rational, and real. All right, I'm going to do one more example with you to keep this video sort of short, but we are going to practice this a lot more. So if you don't completely got this right now, don't worry about it. We're going to do a lot more of these in the next few days. Next example I'm going to give you is something like 0.7. So I'm going to look through. Is it a natural number? Nope. We don't count by 0.7s generally. So it's not 1, 2, 3, 4. 0.7 doesn't fit in there. Is it a whole number? No. Also, not a number like 0, 1, 2, 3, etc. Integers. Integers can be negative or positive, but they must be whole numbers. They cannot be our fractions or decimals. So 0.7 is a decimal. That is a rational number. It's a decimal that stops. So it's rational, and we could also say that it's real. All right, we'll do a lot more examples of these in the future, but I'm going to end it here for today. Good luck on the quizzes assignment, and let me know if you have any questions.